Hello, everyone. I'm Rebecca Bickham, editor of Materials Performance Magazine. And joining me today is Liam Hanna of Edify Technologies. Thank you so much for joining us today.
Thank you very much for having me.
We're seeing robotics being integrated into the industry more and more as technology advances. For those who may not know, what can you tell us about NDT-enabled robotics?
Well, first, let me speak a little about NDT or non-destructive testing and how it's conventionally deployed. So NDT in its very essence is designed and deployed to make sure that we really understand the health and the condition of an asset throughout its life cycle. The non-destructive nature really allows us to understand this information and obtain this information in the most unobtrusive way, whilst getting accurate, reliable, and repeatable data. As you can imagine, assets that require inspecting or testing, they generally appear in hard to reach or dangerous, difficult environments. So by robotically deploying this sensor technology that's already developed by Edify, we're able to get these desired results without having to send humans to these places that we either cannot reach or don't want to get to because they pose a safety concern. Enabled robotics in its simplest form is a robotic solution that's designed to carry a probe, sensor, or a scanner to one of these locations.
Well, thank you for explaining that for us. So now can you tell us how NDT robotics benefit the industry?
Okay, so there's a number of benefits to the industry, and we generally, as an industry, break these down into to four key factors as to why it would be beneficial to consider a robotically deployed solution. So I alluded to the first one, which is of course safety. If you consider, like I mentioned, the type of environments that we're working at height, working inside a confined space, working in a hazardous or dangerous environment, if we can take the human away from that location or that zone and have a robot operating in that environment, then that massively improves safety, certainly of the guy that would have historically had to climb inside something or on top of something. The second one we think about is how we can look at improving our environmental performance. So when we talk about environmental performance, I mean certain assets may have to be drained, for example, to get access to them. If you look at the type of inspection that's being done throughout the world and where assets are located, sometimes there's a lot of travel and transport requirements from a logistics and personnel travel perspective. And again, if you can have a robotic solution that's either static or can be quite simply shipped around at a lower cost and a lower environmental impact, then that's also a benefit. The one that I believe is probably linked around across the board is the ability to try and increase that operational efficiency. So we're not just looking at the safety element and environmental performance element. Actually, robotics are really good at doing a number of things that humans can't do, and that is maintain repeatability and general automation. So a robot deployed to carry out a task is going to do that task over and over again in exactly the same way. So it starts to standardize that approach. At the same time, when we consider the operational efficiency, if you look at an asset, like I mentioned before, if you have to drain a tank or empty a pipeline of the process that's inside it, there's big not only costs associated with that, but there's also the time that's associated with doing this and preparing an asset ready for inspection. If we can bring a solution to site to unobtrusively externally start to inspect an asset without the requirement to empty it or enter the asset itself, then of course the operational efficiency increases. And at the same time, the fourth one, we try to avoid or reduce costs as much as possible. And I think it becomes relatively obvious quite quickly that by being able to inspect an asset with the system working, up and running, in line without the requirement to either shut it down or empty it, and without the requirement for very expensive safety parameters like the cost of scaffolding, for example. It becomes a good solution in certain circumstances.
So, Edify Technologies offers their own NDT enabled robotics. What would you like to tell us about those?
So I think we do have a number of different robotic solutions, both for internal inspection, external inspection, and it varies from vessel inspection, so internal or external vessel inspection, um, pipeline inspection, again, whether that's internal, external. We've got crawlers that will travel more than 1 kilometer through a pipeline, for example. We've got crawlers that will fit inside a pipe as small as 50 millimeters in diameter. At the same time, the one thing I think that um, is often overlooked, but really important, is the way in which we approach enabled robotics or NDT robotics. And that is within Edify, we've got a number of different centers of excellence for different NDT technology. And each one of these centers of excellences will be consulted by the NDT Robotics group to consider the NDT requirement first. And then we look at how we can remotely deploy on an asset.
Well, this has been a great discussion. Thank you so much for joining us today.
I thank you very much for having me again.
Again, we were joined by Liam Hanna of Edify Technologies. To learn more about Edify Technologies or the NDT robotics that they offer, please visit edify.com, EDDYFI.com. I'm Rebecca Bickham, editor of Materials Performance Magazine. Thank you so much for watching today.